Yesterday we worked on writing percent equations. Today we're going to continue on with that, but rather than having 10% or 20%, these percents get a little more difficult and no longer work with the 10 block. So step one, you're going to write your first expression just like we did before. It's going to use either addition or subtraction. You're adding to the original amount for markups or subtracting from it for markdowns. So to do that, you're going to change your percent to a decimal and then multiply by the original amount. Once again, your original amount still represents that variable. You're either going to add to the original amount for markups or subtract for markdowns. Step two is the second equation that you are going to write. You're going to find the total amount paid by adding to the percent. Oops, that's the name. You add your percent to 100 for markups or subtract for markdowns. You'll change that new percent to a decimal and then multiply by the original amount to write your equation. Keep in mind your original amount is going to be represented by that variable. Step three, you will usually have this, but not always. You'll plug in the original value for x into either of these expressions, or if you want to check your work, plug into both expressions to be able to solve for the new price. So example one, a sports store buys two different kinds of skateboards from a supplier. They add a 42% markup to the purchase price so they can make a profit. You're going to write an expression using addition, because it's a markup, to find the retail price of a skateboard after the 42% markup. The first thing I'm going to do is I'm going to change this percent to a decimal. So 42% is really 0.42, or 42 hundredths. I add it to my original amount for the markups or subtract it from the markdowns. Keep in mind, you're going to use x as your original amount. So I have my whole amount, original amount x, plus 42% of the original amount. That's my first equation. For the second equation, I'm going to find the total change in that amount. So I had the 42%, that's the markup, but they're still charging me 100% of the price that they paid. So 42 plus 100 is 142%. So 1.42 of the original amount. Keep in mind that's really just changing your percent to a decimal and multiplying, so you're finding the percent of the original amount. Now I'm going to solve to find two different amounts. So if the store pays $35 for one skateboard and $56 for another, I'm going to find the retail price for each skateboard. So this is the ticket price that you would pay as you walk into a store. So I'm going to use my example for B here because this one seems simpler for me to use. Here I have two variables and I would have to plug in, I'm going to solve for 35 first, I would have to plug in 35 here for this x and then again for this one. So the benefit of doing this is that you're able to use the simpler equation to solve. So I'm going to do 1.42 times 35. That's the 142% of the $35 that the store paid. So I have 1.42 times 35. And I end up with $49.70. Keep in mind, we write it with a zero on the end because we are talking about money. For the second one, I want to show you what it would be like if you use this first example here instead. You're going to plug in 56 because 56 is the original amount that the store paid for this skateboard. So you have $56 plus 42% or 0.42 of the 56. Anywhere you have an X is where you plug in that original amount. I'm going to solve here first because order of operations says I have to multiply first. So I have 42% or 0.42 times 56 is $23.52. Then I'm going to have to add that to the 56. So I add what the store paid, which was $56, to get $79.52. Keep in mind that for a markup, those prices should always be larger than the original amount that the store paid. Example 2 is dealing with a discount. So use some math reasonability skills. Make sure that your new amount is always going to end up lower if you're dealing with a discount. So it says a discount store marks down prices of all of its holiday merchandise by 20%. You'll write an expression using subtraction this time to find the discounted price of any item. I don't know how much these items cost, so I'm going to use X. I'm going to take 20% away from that original amount. So I'm subtracting 20% of X, which really you would write as X minus 0.2X. You change this percent to a decimal by moving it over 2 spaces. Now I'm going to write a different expression to find the discounted price. Well, if they've marked it down 20%, I had the 100% that I was paying, minus the 20% that they're discounting it, gives me 80% that I am paying instead. 80% of a number, you're going to change that percent to a decimal, and you end up with 8/10 of X. It's much easier to see that it's easy to see that B is the easiest example to use whenever you're plugging in to find original costs. So if the original price of 2 Christmas decorations was $16.23, you'll find the sale price of each. I'm going to use this example. So I'm going to take my 8/10 and plug in the $16. That was the original cost. 80% of 16 is $12.80. For this one, I'm finding 80% because they've still marked it down 20% of $23 was my original cost. 80% of 23 gives me $18.40. For your check, it says a bookstore marks down the price of older books which originally sell for $B by 46%. You'll write 2 expressions for the sale price of the hardcover books. So keep in mind, you're not asked to solve anything here. It just wants 2 different expressions. Because it is a markdown, keep in mind that you'll be using subtraction in your first expression, and please use B as your variable. It's giving you the variable it would like you to use this time. Good luck.